This lesson is about scientific notation. In astronomy, we work with very large numbers that are usually written as powers of 10. For example, Earth's equatorial radius is approximately 6,400,000 meters. Written as a power of 10, this is 6.4 times 10 to the 6 meters. As another example, consider the mass of Earth. It is a whopping 6 with 24 zeros after it kilograms. That's 24 zeros. I don't even know the word we use to describe a number that large. It's not million, billion, or trillion. How do you describe it? Well, generally, we simply write this in scientific notation. It's a lot easier and more compact to write the mass of Earth as 6.0 times 10 to the 24 kilograms. That's why we use scientific notation, which is simply a number written as a power of 10. Now, how do you take any number and write it in scientific notation? There are two steps. Step 1, move the decimal. Step 2, count how many places you move the decimal. That's the power of 10. Let's use an example. The radius of Earth is, again, 6,400,000 meters. Let's move the decimal to the left and count how many times we move it. 1, 2, 3, 4, 5, 6. That's 6 decimal places representing 6 powers of 10. Therefore, we write this number as 6.4 times 10 to the 6th meters. Scientific notation makes it easy to multiply and divide large numbers. For example, let's calculate 3 times 10 to the 5th divided by 1.5 times 10 squared. First, divide the coefficients. 3 divided by 1.5 is equal to 2. Then divide the factors of 10. Remember the rule for dividing identical numbers with exponents. Simply subtract the exponents. 10 to the 5th divided by 10 to the 2 is 10 to the 3 power. Therefore, the result is 2 times 10 to the 3rd power. Let's apply this to astronomy. Venus's diameter is 1.2 times 10 to the 7 meters. Sun's diameter is 1.4 times 10 to the 9 meters. How many Venuses can be laid next to each other across Sun? Here's a picture of the Sun. Here's a picture of Venus. And the question is, how many Venuses laid next to each other would cross the Sun? Well, to answer this question, we take the total distance across the Sun, 1.4 times 10 to the 9 meters, and we divide it by the individual pieces, if you will. 1.2 times 10 to the 7 meters, the diameter of Venus. And we just want to know how many of those pieces laid next to each other add up to the diameter of the Sun. So 1.4 times 10 to the 9 divided by 1.2 times 10 to the 7. First, we divide the coefficients, which gives us 1.2. It may surprise you. 1.2 squared is not exactly 1.4. However, rounded, 1.4 divided by 1.2 is equal to 1.2. Then we divide the powers of 10. 10 to the 9 divided by 10 to the 7 is 10 squared. So the answer is 1.2 times 10 to the 2 power. Now, we can do the exact reverse of what we did before and take the number in scientific notation and write it without powers of 10. Since there are 2 powers of 10, let's move our decimal place, this time to the right 2 places, which gives us 120. Therefore, if Venus were laid next to each other, there would be 120 of them to cross the Sun. In other words, the Sun's diameter is 120 times larger than Venus's diameter. If dividing the coefficients gives a number smaller than 1, then move the decimal 1 place to the right and subtract 1 from the power of 10. For example, sometimes you'll come up with a situation like this. 1 times 10 to the 8th divided by 2 times 10 to the 6th. 1 divided by 2 is 0.5. 10 to the 8th divided by 10 to the 6th is 10 to the 2. But this is technically not scientific notation. We need to move our decimal point one place to the right. Therefore, we have to subtract 1 from the power of 10, representing one place. So the answer is 5 times 10 to the 1, and if we expand that, that is equal to 50. What if the exponent is 0? For example, what is 10 to the 0 power? Well, anything raised to the 0 power is 1. Thus, a number like 2 times 10 to the 0 power is simply 2. Of course, a scientific calculator will handle scientific notation for you. To enter a number in scientific notation on a calculator, you use the capital E button. Some scientific calculators may only show a single capital E, but it will be a capital E. For example, to enter 1 times 10 to the 8 on a scientific calculator, you would press the following calculator buttons: 1, EE, 8. And that represents 1 times 10 to the 8 power. Again, the Texas Instruments calculator uses the double capital E. Some scientific calculators only use a single capital E. The calculator will then display the number, and it may display the number in scientific notation as 1E8. Or, if your calculator is not in the scientific mode, it will expand it for you and write the number, in this case, as 1 with 8 zeros after it. The capital E, again, represents the power of 10. In fact, anytime you type a number in scientific notation on a computer, it expects you to use the letter E. For example, on your homework in WebAssign, if you need to type a number in scientific notation, you should type it using the letter capital E. For example, if you want to enter the number 1 times 10 to the 8 in WebAssign, you should simply type 1 capital E 8 with no spaces. The speed of light is 300 million meters per second. Let's write this in scientific notation. We'll move the decimal place over: 1, 2, 3, 4, 5, 6, 7, 8. Thus, the speed of light is 3 times 10 to the 8. In miles per second, the speed of light is 1.86 times 10 to the 5th miles per second. Let's practice expanding a number from scientific notation without using, then, powers of 10. So, whereas before we moved the decimal point to the left, this time we move the decimal point to the right. So we will have 1.86, ready? 1, 2, 3, 4, 5. We move the decimal point 5 places. Thus the result is 186,000 miles per second. Those numbers, 1.86 times 10 to the 5th and 186,000, are identical numbers. One is simply in scientific notation. Let's practice doing this. The speed of light is, again, 1.86 times 10 to the 5th miles per second. The circumference of Earth, that is, the distance around Earth at the equator, is about 25,000 miles. How many times around Earth can light travel in 1 second? In answering this question, we will use many of the skills you have learned so far. Light travels 1.86 times 10 to the 5th miles in 1 second. So let's divide this distance into pieces of length 25,000 miles, which is the circumference of Earth. We're simply finding how many 25,000 mile pieces are in 186,000 miles. First, let's convert 25,000 miles into scientific notation. We move the decimal point. Let's count it. 1, 2, 3, 4 places, giving us 2.5 times 10 to the 4th miles. Now we have to divide. The distance light travels in 1 second is 1.86 times 10 to the 5th miles. Divide that by 2.5 times 10 to the 4th miles. First, we divide our coefficients. 1.86 divided by 2.5 is equal to 0.74. Then we divide our powers of 10. 10 to the 5th divided by 10 to the 4th is 10 to the 1. Now this is not in scientific notation. Let's move our decimal point. We have to move it, in this case, 1 place to the right. Since we are moving the decimal point to the right this time, we have to decrease the power of 10. And so the answer here is 7.4 times 10 to the 0. Now 10 to the 0 is simply 1, and so we can write this as 7.4. Now what does this mean? This means that light travels almost 7.5 times around Earth in 1 second. Imagine that. Before I can even say the word second, light would travel 7.5 times around Earth. That's fast. In fact, we will find later on that this is the cosmic speed limit. Nothing travels faster than the speed of light.